I was going to say lock the doors, but we've got the hardcore crew here. As mentioned, I work for Cisco's Security and Trust Organisation, or otherwise known as STO within Cisco. Just a brief intro, we have three big missions within Cisco. The first is we protect Cisco. So our InfoSec teams, our CSIRT, which is what I'll be talking about a lot today all sit within that function. We also protect Cisco products, so things like our secure development lifecycle, build environment security, trustworthy technology that underpins features like secure boot that you rely on, are engineered out of our group. And lastly, we protect Cisco customers. So we have a whole part of our organisation that runs our trust portal, our public site trust.cisco.com, manages all our assessments, certifications, things like that. So what I want to talk to you about today is really from that protect Cisco. You know, what are we seeing from both adversary point of view from AI, and also what are we doing within Cisco from a defender's viewpoint? So just to give you a bit of a snapshot of our Computer Security Incident Response Team, or CSIRT. Obviously we're a global organisation, so we have a global follow the sun 24/7 model for our CSIRT function. Like your orgs, tier 1, tier 2, tier 3 structure, and you can see some stats there on where incidents or alerts are triaged at the different layers of that model. And so we'll come back to this because when we look at how could AI benefit this function, it's really about how do we address some of the pain points in managing and securing a large global network. We do have a attack surface risk management team, so understanding vulnerabilities across our real estate and managing patching or otherwise mitigations. And we have an intel function that work closely with our Talos threat intelligence team as well. So start on the adversarial side of AI. What do we see attackers doing, or how they empowered and using AI themselves? So I thought I'd start with Talos. So Talos is our threat intelligence team. They produce quarterly and annual security reports. And I thought, go back to last year. I know we're almost at the completion of 2025, but what were the threats that we saw, or what were the techniques we saw actors using in 2024? And it was really around that, using generative AI and large language models for better social engineering. So, crafting better phishing emails, but also doing targeted research on the victims so that they're crafting the phishing email to represent an individual or a sector or a company. So really trying to improve, from their point of view, the confidence that people might have in clicking on a link or taking an action. The other side of where actors, malicious actors were using AI was really just like all businesses. It was really in that efficiency and productivity. How do I do task automation? Their coding cycle is to build malware. So how could they, more efficiently work on their software development processes with AI assistance? And Talos finished off with some predictions of what we would see this year, or potentially. And, like in enterprise and our businesses, the rise of agentic AI is something that's, was predicted for malicious actors. Continuation of social engineering at scale, better phishing, better spear phishing techniques. There's big concern on automated vulnerability discovery. Like, could 0 days be automated from an AI tools? We're going to go out and build malware. And a switching to, how will attackers attack actual AI infrastructure? Go after the models, or go after tools or AI deployments within the enterprise. So looking to this year then, in 2025, and there's a couple of good blogs from Talos that you can go search on their website and hunt down. The first one there is using large language models for reverse engineering. Okay, so this Talos blog steps through the process of using agents, so using Model Context Protocol, which we've heard about, to front-end tools like IDA Pro, which is a reverse engineering tool commonly used. And so now they can use an LLM, locally hosted, cloud hosted, and have that LLM, or that model, go out and do the reverse engineering, drive the tool and present the results back. Now, The Talos example is in their setup, and they've got all the steps to recreate this, was so they could reverse engineer malware more effectively. That's one of the jobs that they need to do. But you can see in the, how malware or vulnerabilities work today. A couple of years ago in the Australian Cybersecurity Annual Report, so I know there was one published just last month, but if we go back to last year's report, they had some stats on the window between when a vendor produces a patch and then how long it took to be exploited in the wild. So how long did it take a threat actor to take the patched binary, the vulnerable binary, work out the diffs, reverse engineer it, and develop an exploit? And so in 2024 annual report from ASD, in 1 in 5 cases of what they looked at, of CVEs, that time was less than 48 hours. And then when you go to 1 in 2, we're done within 2 weeks. So when you look to advice from the Essential 8 and the different maturity levels, you see this focus on patch everything that's internet facing within 48 hours, because that's the current pace by which threat actors are developing exploits once a vendor, Cisco otherwise, publishes a patch. So the risk is that AI will supercharge or like we're seeing 2-fold, 3-fold, whatever increases in productivity. Will that 48 hours going forward become 24 hours? Will it become even less? And that's why I'm not talking about today, but moving into new approaches to how we deal with patch management, like Live Protect, which is already available on some of the Nexus switches, that ability to put other mitigations in to give you that real-time protection or more immediate protection and give you a longer time to catch up with patch cycles. The other blog, just briefly, was Talos have been looking at just general usage of large language models and some also good results or good reports from OpenAI and looking at how threat actors are maliciously using their public models. And so, that targeted analysis or open source intelligence research on victims before they do crafted emails. But Talos see to try and defeat guardrails is always a challenge. If you ask one of the public LLMs to do something which might be considered illegal, generally you'll get some advice back. It's sometimes quite frustrating if you're in the security professional space and it's just a legitimate question. But there are a number of models which have no guardrails, by design, or malicious, deliberately built LLMs which don't have guardrails, so they don't have those safety protections to stop people asking, how do I craft this, or how would I develop an exploit for this platform? So that's the other observation from this year. Now, before we go on, one of the things that Cisco is heavily involved in is the Coalition for Secure AI. And so we look at, as a CSIRT function, we need an incident response framework that's been updated for AI threats or just the general AI environment. And so up you can see here is to define different types of incident categories. So not all of them are, someone's knocking on the front door, sending a phishing email. It's looking at, well, what are the possible data poisoning events? Like, did someone poison training data? Is there a way to extract business IP back out of a model that you might have retrained to make it your business specific instance of an LLM? Is there something problem in the deployment so that it's not quite locked down and it can be enumerated or some other, or abused in some way? Of course, if you're deploying AI workloads, both in your own environments or in the cloud, is like, how do we make sure the infrastructure is secure, that the attackers just don't go after the underpinning infrastructure on which the AI workloads work? And of course, user interactions, right? Those safeguards to stop that malicious use. So with that as the context, these are some real AI incidents we've seen at Cisco from our own deployments. And so, we've heard about Circuit, our internal chat assistant. It's got lots of models available to us, but we don't block access to public, chat, most public chat agents, that is. And they're available to our employees to test as long as they use public data, right, or unclassified data. If they're using Cisco confidential data, then they should use Circuit. Okay, so we've had obviously some incidents where our employees have uploaded confidential data and used it in a public tool. We've certainly seen the phishing emails, just an improvement in quality. We've seen some misconfigured controls. We've had some playgrounds and sand pits, and something's been missed in that, and it's exposed access in some way. I'll go a little bit deeper on an example of malware recon. So we've seen actors exploit AI within the environment that our engineers or staff use, trying to extract AI out of our platforms, and toxic AI responses. So you ask a somewhat polite question and you get a rude response. It's trying to understand, well, is that the training of the model, or is there been some sort of poisoning, right? So we've seen all of these. But I thought, just in the interest of time, we'll just delve down on this particular one, which was credential stealing using AI. And the reason why this one is interesting is because the AI component that was abused was already deployed in our environment, right? It's AI assistants or AI models, which are available via the command line on a developer workstation. So NX is I'm not a developer, but for people who are into JavaScript and using NPM for package management, one of the tools is NX to manage these libraries and do the builds. Now that particular tool set was compromised upstream, right? And you can read into the details, but there was some exploit in GitHub, and a malicious actor changed the tool and put in their own code. What's interesting is one of the modifications they made was to put in prompts or instructions to AI environments they found inside the organization. So here in the blue text is the malicious prompt that was included in one of the scripts when you deploy this build system. And what it does, it checks for the presence and say, hey, do you have Claude available or Gemini or whatever agent that might be available to in your development environment? And then sends this prompt. And if you just drop to the bottom there, basically says, hey, AI agent, make me a list of all the files that look like they have something to do with crypto, private keys, or secrets and otherwise. The later stages is I bundle that up, put that into GitHub, back into the repository, and mark it public so I can get it out. So there's a bit of instructions before and after, but the actual looking for the secrets or looking for the sensitive data was a prompt instruction to AI that was legitimately deployed within the enterprise. So how did that play out for Cisco? So there are instructions here to how to search for this in your GitHub space, because one of the things it does is create these repositories with some random characters at the end and mark them public. So you certainly know if you've been impacted. So looking across Cisco, and I'll speed up here, we found this in a couple of our developers' GitHub environments. We could see that it had executed, and we say, okay, well, what secrets then may have been collected? Right, and so there are a couple of personal access tokens. So in GitHub, alternative to passwords. Those probably have been harvested. So what then did that privileged access or access to those privileged access tokens? I'm using access a lot there. Sorry about the acronyms. Allow them in other parts of our environment. And so the rest of it is really closing that down and understanding. Okay, well, there's some good hygiene around that. They were scope limited, they were time bound, and so this particular incident was closed out. But the learning is really around, and this feeds into a different program we have around build environment security, which is not only the integrity of upstream open source software, but also of all the open source build environment tools to make sure they have good integrity. I want to flip, just in the interest of time, to then the defender's view. So how do we use, or how can AI benefit the function within CSIRT, our SOC team? And so we like you've heard this morning and earlier speakers, we encourage everyone to experiment, especially the people who do the day jobs. What would make your life easier, or what are the problems that are difficult to solve because of scale or volume, or things that machines are good at doing that take a lot of brain power for humans, or just too much time. And so they fell into these 6 initiatives. Okay, so the first one there is plays as code. Sorry. So we use Splunk internally for a long time. We have a playbook, and we have a lot of very structured plays, search queries, enrichment from other sources, and some of those are automated. Some of those, open cases. What we've been working on doing is turning those into plays as code, which is really bringing some software development techniques, like revisions and so forth, but one of the outcomes is to make those from less rigid rules-based to more, these are the steps you take and these are the outcomes or the goals. And the reason for describing this way is because then it becomes instructions that you can give to agents. These are the steps I want you to take. And this is what the output or the goal I want you to perform. So a lot of work in that space. We've developed a lot of analyst utilities for different functions, especially if they're very time consuming. And I'll go through a few of those. One thing LLMs are good at is summarization and producing insights and metrics. So there's a whole focus on that. Insider threat detection. So I mentioned, that use case of, staff using the wrong tool for the wrong data classification around how do we use AI in that? Because it's very difficult to determine the sensitivity of all data that's uploaded because, just relying on document tagging, doesn't work for all, unstructured data types, basically. Carl mentioned this morning, if you're here, this idea of a security LLM, and we've published Sec Foundation or Foundation Sec 8B, 8 billion parameters, right? There's a couple of variants of that since it was initially put out. There's now an instruct model, so you can use it in a conversational manner. And there's a preview version of a reasoning version of that model, so you can give it more complex tasks. And so the reason for having a security-specific LLM is much like you might be aware there are legal LLMs that are well-versed in legal law and cases. There are health LLMs to support, health professionals and doctors that it really knows, what might be wrong with humans. So the security LLM has been trained, so it knows what attack life cycles look like. It knows how incident response processes work. So when you want that expertise in your environment, you can download this. We published it, and there'll be a reasoning model out soon. We use it internally within our CSIRT for some of our initiatives. And the one I'm going to talk about is this co-analyst. So we built a tool when we look at some of the pain points. I'll jump to the next slide. Our pretty standard sort of SOC. We've got a SIEM. We feed it lots of alerts and telemetry. We have some other tools that we use for lookups or specific domains. As I said, we've got a playbook with hundreds of plays of the things that we know that we need to detect. And some of them are somewhat automated. If we have a high confidence that, okay, we know that there's malware and we know what type of malware it is and we just don't want the employee to re-image their machine, we can somewhat automate those sort of, high confidence tasks. Other ones, open tickets for IT to potentially resolve. So the challenge in that model is for Cisco, we're seeing our logs double every 12 to 24 months, right? The attack sophistication, the changes means there's always a constant challenge to keep those plays and the detections up to date. We have obviously a lot of cloud, as I'm sure your environments do. So there's a lot of ephemeral resources. And so, containers spin up and spin down. And so where did that telemetry come from? Or what is that posture if the device no longer exists? So, there's a lot of limited time or limited lifetime assets that we need to manage. Obviously, we've heard a lot, and Julie covered this earlier, around the skill sets required, right? How do we bring not all people in Cisco, but also our security teams to give them those foundations and AI skills? And obviously, I'm sure in your own security teams, this constant fear of analyst burnout, right? Because it's a very busy, demanding job and the threat, landscape is not slowing down. So what if we had an AI-enabled SOC? What would we want a SOC co-analyst, so not to replace them, to hand in hand to try and alleviate some of those problems? So we'll drill down into that blue box a little bit, but one of the things we've got to have in mind, what are the goals we want a SOC co-analyst to do? What are those problems from the previous slide that we'd like to be solved or like to be reduced? So we'd like to reduce the false positive rate, right? So we want a better handle on what's the likely verdict of this investigation. We also need to know, well, where do we focus first? There's lots of things to look at. So what's the severity? Which is people should get out of bed for, versus which ones we can leave till next business day. That focus on writing notes. So there's a lot of case summarization, handoff between engineers. I mean, that takes time. So how do we reduce that? And because we're a co-analyst, explain what steps we've taken and then also recommend what steps need to be taken next. for the human analyst. So, somewhat busy slide, but this is how Stock Co-Analyst works today. So, we have events come in. There might be a detection or an alert out of a SIEM. It might be reported through, employee reporting something through email. But it kicks off, okay, what type of event is this? And then we say, what player's code do we need to draw from? Is it a malware incident? Is it data loss? At least give some guidance. One of the first things we do is say, well, we may have seen this before, and we don't want our co-analysts to be a beginner every time. We want them to have some of the experience of the smart people within Cisco CSIRT. So this blue box down the bottom, I'm sorry if I'm blocking your view there, is we take all of our previous case notes and then we run them through an LLM, and its job is to pull out the interesting data and normalize them so they're a standard, structured, common format of case notes, right? This is the history of how we've seen incidents in Cisco and how we've resolved them. And then we feed that into a vector database. Okay, so this is the whole RAG model we heard earlier about retrieval augmented generation. And this is giving the LLM some specific knowledge around, well, this is how Cisco CSIRT works, and this is the type of incidents and how we have generally solved them. So pulling those two together, a player's code or a set of steps, along with some experience from what we've done in the past, it creates an execution plan, right? And then some of that is now where we have agentic AI, and we go off and talk via MCP to various tools and say, oh, I need to go look up in VirusTotal, has this been seen before? Or I might go to Cisco Secure Endpoint, to the AMP cloud, and say, is this a known malicious hash? What's its disposition? So we can pull all this together through a number of steps and then ultimately produce the AI co-analyst's view of, here's the report. And then we run it through a validator, so like a double-check LLM to make sure, yes, that does seem reasonable. And then we hand it off to our analysts, and they get like, is it likely to be a true positive? What are the steps that have been taken? Explainability of how it came to that decision, and then recommended steps of what to do next. So, all of this is building on, and other tools. There are a couple of ways if you want to look at this yourself. One of them is go to, just go to a search engine, look for Foundation Sec 8B, trace through the announcements, but you'll end up at the GitHub page that we publish for that particular model. And in there, there's cookbooks for a lot of these functions. So if you want to do there's a cookbook for end-to-end incident handling. There's a cookbook, examples of how you do case summarization. So you don't have to start from scratch. We've published a lot of guides to help you get started if you're going to build your own agentic solutions, using LangChain and LangGraph, etc. On the other hand, we're also customer zero, so CSIRT work very closely with our product BUs, like Splunk, and you can see the AI tools, the MCP server and stuff that's come to that platform. If you look at XDR, which I know is in World of Solutions, some of the additional functions that have come to that platform, such as case summarization and incident summarization, you can see that we've had a hand in helping craft and provide input into what the security teams need out of some of the platforms you might purchase rather than build. So, expected improvements, because we're still measuring how we're going on these, but because we have a good handle of where our engineers are spending their time and how long it takes to look up and enrich some of these sources, I think 25% SOC efficiency, incident response time improvement, because we're going to get from at roughly machine speed or as fast as AI agents can work to go away and do the processing, get to that initial report to our tier one analysts much faster. And that predictive score on, is this a true positive, a false positive, or just benign? And I don't have stats here, but we have a huge portion of benign incidents. You look into them and they're nothing, right? So we want to just drive down that false positive and get up our true positive detections. A couple of other, I mentioned we've built some other tools. So another one is zero-day vulnerability analysis, or really, I guess, day one vulnerability analysis. So when a CVE is published, one of the first questions most organisations ask themselves are, do I need to worry about this one? Does it impact my environment? And so without stepping through the flow here, we pull together sources of information. We go out and say, okay, let's go pull information about the CVE. Let's go pull out other write-ups on potential, are there threat actors abusing this CVE? Are there TTPs we should be aware of that are associated with exploitation of this vulnerability? Tie that together as, well, what assets within Cisco might be running, that vendor, that version of code? What's our exposure? And then go through, well, how do we prioritize that? Where do we start if we say like we had 100 assets? Well, then we go out and say, well, which ones are internet facing? Right? Back to the ACSC advice, start with your internet facing because they're going to be exploited in a rapidly shorting window. So all of that is built in like Jupyter workbooks, pulling on LangChain and other tools and LLMs to get that answer really, really quickly, right? That's the goal. And this saves us a huge amount of time, especially if you've got an enterprise, an organisation with a large number of assets, a large number of vendors, and you're keeping track of a large number of vulnerability announcements. The other big tool is Data Insight Genie, and this one saves an immense amount of time. So if you have you're called out as there's been a data dump on the dark web and someone's selling data and your company's mentioned in it, well, what is that data and what is its real value? Right? A lot of times, some of it is low value data, some of it might be quite intellectual property and so forth. And so to answer that question, what we want to know is, well, was there intellectual property in there or customer data? Was there source code? If there was source code, is it open source? So you could have got it anyway, or was it Cisco source, which we'd be more concerned about? Did it have creds in it? Have we lost secrets? Are they going to be abused to get back into the system or into other systems? And who are the impacted users? Right? If we need to do things like, hey, be aware, personal details are being shared, expect some sort of targeted phishing campaign potentially, right? Because they have some context around where you work and who you are. Or we need you to, you need to rotate your credentials or take whatever action, right? So these are good questions that we need to do or need to answer. So we built this tool, some stats there. It does, when they tested through, 123 email analysis per minute. And if you assume a human analyst would take maybe a minute an email, you can see the human equivalent resourcing that's required just to read through some of this data and make these determinations around what was in their customer data, intellectual property, Cisco's and otherwise. So big time savings. If you go back and look at late last year in 2024, it's all public. You can look it up on our disclosure page. We have a developer platform called DevHub, and there's a configuration error, and large volume of data was exposed, right? And somebody accessed it. Now, going through that, and if you go through the write-up, it took weeks to analyse through what data. We knew what the data was, but it took us weeks to work out its sensitivity because it was a community site for developers. And so most of the data there was just sample scripts. It's things that we produced to get you started. And so a lot of it had no value really, right? You could ask me for it, I'll give it to you, right? But there were some files in there which were sensitive, right? And so to pull those out and find them with humans took a long time, which is one of the drivers why we have Data Insight Genie now. The final one, this is just a walkthrough. So data breach analysis, get the data set, put it into a forensics data store, and then we have a number of AI-powered analyzers that do email analysis, document analysis, source code analysis, using both LLMs and machine learning and data science, Python libraries, to give us some reports on who are the email people impacted, what's the sensitivity of the data and so forth to allow us to then kick off things like, containment, customer and legal notifications and so forth. So a really important process to optimize. The last one, that was I thought I had one more example. Let me just jump back one. No, that was my last utility. We have built others. So to leave you with key takeaways, and There's a lot to keep track of in the adversarial AI space, but from a defender's point of view, when we looked at the challenges in our SOC, it's almost mandatory, or you should really look at how can AI help optimize workflows on the defender's side, right? There's a lot of very time-consuming tasks with very big data sets with a never-ending volume of things to triage and investigate. As Julie said, start with building skills in your team. So, we spend a lot of time encouraging people to, programming, learning Python or the basics is not that difficult. Understand AI, what it works, what MCP is. So get people familiar with what it's capable. Importantly, inventory your AI assets, right? So if you're going to run the AI framework, which is the last one there, you need to know, well, where is AI in my organization? Either inside or within my cloud providers, both, because you need to worry about all of those threat categories around, well, who's responsible in a shared responsibility model to deal with, training data poisoning. Or if it's deployed within your organization, obviously you own more of the responsibility to address more of those threats. So again, go to the Coalition for Security of AI and have a look at the IR incident response guide. It just went formally version 1.0, I think, like about 2 weeks ago. So it's fresh off the press from being developed. So I think we're stopping pretty much on time. Thank you very much. And if you've got any questions, please drop them in the WebEx space. I'm always happy to be followed up, or stalk me on LinkedIn and I'll get back to you. Thank you.